All right, we're going to work through some application problems using the trig ratios and basically word problems. So for all these problems, we're going to be drawing our right triangle over and over and over again. And the key is you draw the right triangle and then you label. You don't have to do anything fancy. You don't have to draw a ladder or draw whatever else is given here. Just draw the right triangle and label it accordingly. So the first one says a ladder leans against a wall resting at a point on the wall that is 48 feet above the ground. So a ladder leans against the wall. Well, if you look at your triangle, this has to be the ladder. It's the one that's leaning. Walls we're going to assume are vertical. The ground we're going to assume is horizontal, and there's always a 90-degree angle between a wall and the ground. So 48 feet above the ground, that means that 48 is going to be the wall side. The ladder makes an angle with the ground of 60 degrees. So my drawing isn't exactly to scale, but down here, this is going to be 60 degrees. It's the angle between the ladder and the ground. I'm going to find the length of the ladder. So that's where you put your variable. So you label your unknown with an X, and then you see what you have and what you're trying to find. Relative to this angle, this is the hypotenuse, and this is opposite. So if you think of your trig functions, we're going to use sine because it's opposite over hypotenuse. So then it's just the sine of 60 is equal to 48 over x. We're going to convert to a 4-digit decimal. 660 over 1 is equal to 48 over x. Cross multiply, 0.8660x is equal to 48, and we're going to round to whole numbers again. So x is approximately 55 feet. The key to all of this, I mean the work is the same as yesterday, the key is just drawing the correct diagram. So the next one, a person is sitting in a boat, and that boat is 186 meters from the foot of a lighthouse. So this word sometimes creates some confusion. Your feet are on the ground, right? So the foot of a lighthouse is at the bottom of the lighthouse. So here's my triangle again, and it's 186 meters away from the foot of the lighthouse. So the 186 has to be at the bottom. Because we're going to put the boat down here. The boat's here. The lighthouse is over here. To look directly at the top of the lighthouse, the person must raise their eyes to an angle of 27 degrees. So if I'm looking up at the lighthouse, the 27 is the bottom right again. And we want to know how tall the lighthouse is. So the x, the vertical height, is what we're trying to find. So relative to this angle, 27, we have opposite, or we need to find the opposite, and we have adjacent. So we got to remember which one of these functions uses opposite and adjacent. And it's got to be tangent. So the tangent of 27 is equal to the opposite over the adjacent. So 0.5095 over 1 is equal to x over 186. When you cross multiply, you will end up with x as approximately 95 meters. For the next two, I'm going to give you the values, and you are going to label the triangles, and then we'll check them in class. So I have the right triangle. You need to draw that one. You need to draw this one. And then a supporting wire 12 feet long is attached to a flagpole at a point on the pole that is 9.5 feet from the ground. So there's your value that you're putting in. And we want to find the angle this time the wire makes with the ground. That is, remember we had to do that on 2 lessons ago. And then for the fourth problem, a kite is flying at the end of a 20-meter string. If the kite makes an angle of 54 degrees with the ground, how high to the nearest meter is the kite flying. Again, I want you to set these up and see if you can solve them, and we'll check them in class. Alright, so this one we'll do together. A straight road is inclined upward at an angle of 16 degrees with the horizontal. So this always gives kids a little bit of trouble to draw. A road is inclined upwards at an angle of 16 degrees with the horizontal. Horizontal is the bottom. The road is going to be the hypotenuse. And here's where my 16 degrees is going to be. If you walked a distance of 2,500 feet, oops, I'm going to make that 2,500, up the road, we want to know the increase in altitude. Now remember, the altitude is the vertical height. So I'm trying to find the vertical height, and I'm walking on the road. So the road is the ramp there. And that's how you set that problem up. So relative to this angle, I have hypotenuse and I have opposite. And that means we're going to use the sine function. So the sine of 16 degrees is equal to x over 2,500. 0.2756 over 1 is x over 2,500, and x is going to be approximately 689 feet. Again, it's really all in the setup. Okay, for problem number 6, for each 12-foot horizontal distance, and I'm missing a letter there, a wheelchair ramp rises 1 foot. So this is different. I'm going to help you set this one up. For each 12 foot of horizontal distance, so if I'm moving along 12 feet horizontally, I then move up 1 foot. That's how you draw that. It's a little skinny triangle. And I want to find the angle between the ramp and the horizontal. So I'm trying to find this little bitty angle there. So that's where we're going to put x, right in there. Here's my right angle. So relative to that, I don't have the hypotenuse. I have opposite and I have adjacent. That should tell you that we have to use the tangent function. So the tangent of x is equal to 1 over 12. This is one of those where you have to find the angle. So x is actually the inverse tangent of 1 over 12. And when you round to the nearest degree, x is approximately equal to 5 degrees. Number 7 we'll do in class, and number 8 we're going to do in class. But let me jump down to the last part here. Alright, here we have a rhombus, A, B, C, D, which I need to label. So it doesn't matter where you start labeling as long as you go around. A, B, C, D. CAB is 25 degrees. And AC, which is the diagonal, is 18. We want the perimeter of ABCD. So you have to remember some properties of a rhombus. And one property of a rhombus is the fact that the diagonals form 90-degree angles. So I can create right triangles. Now, if the entire diagonal is 18, the diagonals bisect each other, which means this side is going to be 9. So here's what I have. I have a right triangle. I have an angle of 25 degrees. One leg is 9, and I'm trying to find the hypotenuse. Because once I have that, if I add all the way around, I'll have the perimeter. So, which trig function do I use? This is the hypotenuse. This is adjacent. And you should know that you're going to use the cosine. So the cosine of 25 is going to be 9 over x, because the hypotenuse is the actual side length we want. Cosine of 25 is 9 over x. 0.9063 over 1 is equal to 9 over x. And when you cross multiply and divide, you end up with x is about 9.93. So to find the perimeter of that, you're going to multiply that by 4. You add that 4 times. Hold on. The perimeter is 4 times 9.93. and you get about 39.7, or roughly 40, because that's roughly 10. That's the perimeter of that rhombus. Now the length of BD, well, the length of BD is going to be twice the length of the other side. So see if you can figure out how we're going to find the length of BD. Alright, the last problem we're actually going to go over in class together, but I just wanted to label it so you could set it up. In trapezoid ABCD, A is going to be at this bottom corner, and then we go around this way, because BC is going to be 9 and AD is going to be 15, and this angle is going to be 35 degrees. So we're going to go from there. We're going to figure out how to find the area and the perimeter of ABCD. But again, we're going to do that together in class, just to give everyone more practice and working on some of these problems on their own.